Welcome to Wood Facts with your hosts,
Glenn and Jess. And today we're going to answer the question, why does wood shrink?
Okay, so before we get into the how and why of wood shrinkage, there are three terms that everyone needs to know. The first being equilibrium moisture content. So this is the moisture content attained in wood exposed to a given level of relative humidity and temperature. Okay, the second term will be bound water. And this is water vapor molecules that are chemically bonded to a cell. When it leaves wood, it will shrink. The third term that's important to know is fiber saturation point. So this is the point in drying wood when bound water leaves and wood begins to shrink. This is approximately 28% moisture content. Now that you understand the three key terms in wood shrinkage, I'm going to show you the different ways that wood can shrink. So the first would be longitudinally, this way. The second would be radially. And the third would be tangentially, this way, through the annual rings. And that is the one that is most affected, and it shrinks approximately 8% in wood.
Okay, next we want to introduce to you how wood shrinks. We'll start off with the basic point that all wood in growing trees contains a considerable quantity of water. Okay, as mentioned before, water in wood comes in the form of free water. In this diagram would be the area in the middle. It also comes in the form of bound water, which is within the cell walls along the outside here and here. With the removal of free water, this is actually what we do when you kiln dry wood. From the green process to kiln dried lumber is you're removing the free water. This does not affect the dimensional shape of wood, or it does not shrink when free water is removed. The bound water, however, when removed, is the number one cause of wood shrinking. Another way to explain this phenomenon, called wood shrinkage, is if you can imagine, as long as the fiber saturation point is maintained at 25 to 32%, wood does not shrink. However, as the moisture content decreases and the bound water leaves the cell walls, a vacuum between the wood fibers replaces where the water used to be. It is this vacuum effect between wood fibers that's drawing the fibers tighter and closer together, and is the result wood shrinkage from the decrease in the EMC or the fiber saturation point dipping below 25%.
Okay, so wood shrinks due to a loss of bound water. And there are many factors that can affect this, such as temperature and relative humidity. For example, if you think of a door in the winter, the weather is cool and there's a low moisture content or humidity in the air. Therefore, the bound water is being lost and the wood shrinks so your door opens and closes easier than in the summer when the moisture content in the air is high. In the summer, you will notice that the opposite actually happens. Due to high humidity, the bound water increases and the wood will swell. So in conclusion, if the moisture content drops below the fiber saturation point, the wood will shrink. So now you know a little bit about wood shrinkage.
And thank you for enjoying this presentation on Wood Facts by Glenn and Jess.